Okay, you setting it up pretty well.
Let's see.
But what is all that equal to? What is f of x equal to?
5.
Yep. So write it in. Your full equation is, yeah. Okay. So now, well, okay, now slow up. You put the 5 in there, you shouldn't have.
I shouldn't have.
Yeah. Because it's f of x. The whole function is equal to 5. Remember? There you go. Now you have to do some order of operations and find like terms. And should be that hard for you.
So I couldn't. I may have been thinking about something wrong, but I couldn't say
Well, you can cancel all those fractions, right? Like you did last time.
with the.
So what would cancel the fractions? You said what?
If I made the denominator all 3.
So you need to do what to make everything happen? You should multiply the whole thing by 3, right?
Right. So I have to put the 3 in the front.
No, you want the whole, because what you do one side, you do the other, right? So, let me help you out. So if I took this whole problem, it's 4x minus 1 plus 6 over 3, and I said, boom, boom, I multiplied that by 3. What happens to this whole thing?
Oh,
We talked about
15.
this before, right? Yeah. So when we do it,
That's
1,
there, and then that's going to go over there.
so 3 times this is, we're going to do one more because you said you had to. This is going to be 3 over 3. The 2 is going to fall, right? Because it's 3 times that, this fraction here. So no, because the 3 over 3. That's why I did that. Changes the fractions to just regular numbers. So 3 over 3, that leaves 2.
Okay.
Because they cancel.
Cancel.
And then this whole thing just comes down, because this is all in the numerator. So it's going to be 4x minus 1. And then 3 times that, 3 is in the denominator, right? And then 3 will be in the numerator, so 3 over 3, that leaves plus 6. We're going to do one more, because you said you had issues with the fractions last time.
Wait a minute.
I'm good. So what's wrong?
I'm thinking about another type of problem where we did work with the fractions, where the denominators are the same, then you can
That's what you did. You took the number in the denominator, and you multiply the whole equation by that number just to reduce the fractions to whole numbers. You follow? We'll do one more. But now it's in the form you need where you can just work with it simply. Because if I didn't multiply it by the 3, you have to deal with each of those fractions. But when I multiply, because essentially we did the algebra by saying the whole thing needs to be 3. Because what you do on one side, I could have just multiplied this by 3 and multiplied this side by 3. But I just said put in parentheses, multiply everything by 3. So when we did that, 15. This is going to be, you said 6 because you're multiplying it. But the purpose was to drop that 3 off of there so you had no fraction.
Well,
So,
I probably would have did it the long way.
You still had to
put
reduce it.
6, and then I would have
It would
reduced
still have been
again,
6
so-
divided by 3, which is still 2.
Right, I would have did it the long way.
I know. I did it like a physicist or a scientist would, but
Yeah.
I'm basically simplifying it so you can get to the problem.
Okay. So
Because
I
you
did
had
it
an
the
issue
long
with the
way.
fractions.
Yeah.
Yeah, well, you would have still multiplied it. The fraction still would have dropped down to this. I just did a step advance because I said, all right, I know this is 3 over 3, that goes away.
Yeah.
I know that's 3 over 3, that goes away. And everything just fell down and made it easy for you.
Okay.
Cool?
So then, yeah, I'll say 15 equals 8x minus...
You write it. Don't tell me what it is. Write it.
8x minus plus 6